In this video, we're going to look at keystores and SSL and TLS certificates inside of IHS, which is essentially Apache under the hood, and the WAS plugin and how WAS comes into play. So these three products and how their keystores all integrate. Okay, so remember the flow. Your client goes into IHS. That request is for HTTP, of course, and the client will mention some sort of URL string, we'll say some, and then the plugin will see that you're trying to reach some, and so it's basically like this. Now it's come in here, it's now gone in here, and then the plugin sees some, and then it sends it out to WAS over here. WAS will see that /some, and then route it to the appropriate JVM. So we've seen that before. And then of course in return that path goes backwards, right? So it goes back through the plugin and then out through IHS and then ultimately back to the customer here or the client HTTP web browser. And because this is a video about keystores, obviously this communication here is happening not over HTTP but HTTPS. So also notice the multiple keystores that you have, 1, 2, and in the case of WAS, you have many keystores. Each of these keystores, by the way, match up to each node. So if you have two nodes, you'll have at least 2 keystores. But there's also this third keystore down here, which is the cell default. And the idea here is that if you don't provide a keystore for node 1 and 2, the cell default essentially gets copied into that node 1 and node 2, so it has the same keystore as the default would. And then lastly, in the case of WAS here, there's a CMS keystore, and this keystore actually refers to this keystore here. Now why would it do that? Well, the idea is that if you add a new key here, a new certificate I should say, if you add a new certificate here, which of course contains the public key of whatever it is that you're trying to add, when you do that, this same certificate here will be copied into this plugin here, into the keystore in the plugin. And so CMS keystore actually refers to the keystore on the plugin. And that copying is called propagating. And you'll also see it listed under generating. So you're propagating that plugin to the plugin. This has a really nice advantage, which is that instead of manually issuing multiple commands to import and also copying the key over from here to potentially multiple nodes, right? This is just a single node, but imagine you had 5 or 10 nodes out here. You would have to, if you did not have this propagate option, you would have to manually copy it over the network, and then you would have to add it to each of those keystores, and that's just a major pain. So having the propagate option, it will save you a lot of time. Okay, so let me show you what I mean. So if you log in here to Websphere and you go to security, SSL, and go to keystores and certificates, take a look at what you have. So here is the CMS keystore that we talked about, and notice where it goes to plugin-key. So that is indeed the plugin. And then also you have the default keystore for the core cell, so that's essentially the default like we had explained. And then you also have these ICFM nodes and CFM nodes, and they're all essentially nodes. So these are all the keystores for all of the additional nodes. You'll also see the trust store listed here, and there's even a default trust store, and that is what will hold your certificate authority and all of the intermediate authorities. So the idea is that the key store is essentially the leaves, and the trust store is used for all the CAs, basically whatever signed your leaf. Now, to find the option about propagating and generating, you can go to servers, all servers, then go look at your web server, and then under action you'll see both generate the plugin and propagate it. So generate will generate the plugin and also update it, and propagate will copy it over like we talked about to all of your federated nodes. So that's nice because you have a web GUI to copy all of these additional certificates off to the individual nodes, of course. Also, notice the WAS terminology here. So you have what's called a personal certificate and you have a signer certificate. The personal certificate contains the private and the public key of whatever certificate that's involved. But if you extract out the public key, then this is referred to as the signer. And that's explained here about personal and signer certificates. And if you are curious where you can find the private certificates, they're listed in these formats. Now, the problem we have here is that this WAS piece and this WAS plugin can, of course, talk to each other. But what they cannot do is interact with the IHS key store. So in other words, these key stores here can all connect thanks to the deployment manager installation, your distributed WAS infrastructure, but they cannot talk to this key store. So if you need to add a certificate, or if you need to remove the default certificate from IHS, you can't do that from inside WAS. The other important thing here is that whatever keys you have listed, and really they're certificates, but of course some of those certificates could include the private and public keys, but let's say certificates for simplicity. The certificates that you have on IHS must also be, this one here, must also be inside this plugin. It must be listed in the key store here. And that also applies for WAS. So whatever you're using, and very often it's just a single cell default for all of these, whatever that certificate is, or whatever those certificates are, those must be in the key store here as well. So the reason for that is because, as I've drawn here with the in and the out, the server, in the case of IHS, must encrypt and decrypt information from the client here, and it needs a private key to do that. So but the public key is what the plugin needs. So again, we're talking about the personal key here for IHS, but you extract it, you get the signer, and so of course the signer needs to be here in that plugin, and that is the signer from IHS. And then of course these signer keys also need to be in that same key store. Otherwise the plugin, which has to translate between IHS and WAS, won't have any way to encrypt and decrypt all of the information coming in and also going back out. So that's very, very important. So in order to see the personal and signer certificates, what you need to do is go to Security, SSL, Certificate and Key Management, then go to Key Stores and Certificates, and then select the store that you're interested in. So let's look at the cell default key store, and you'll see on the right personal certificates and signer certificates. So the personal certificates for the default store look like this. There's a serial number, and you can see there's a hierarchy. This is the root, and this is one of the leaves. And then if you go back and look at the signer certificates, you'll see there aren't any in this case. Now let me demonstrate how the certificate that's in this key store must be in that key store, and the certificates, we're just going to see the one in our case, but the certificates that are here must also be in that key store. First, let me show you the certificate that's in here. First, I'll issue an export command, which allows us to run the ultimate GSK kit command that we want to run to look at the certificates. When I hit enter, notice that we have these three certificates. We're interested in this one because it is the main IHS key. So if I run a command to extract out the serial of that key, that certificate, we get this. Now let's look at the plugins key store. So I'll run this command, which will show us a list of all the certificates in this key store. The very first certificate says we have this, so let's look at it. And that, by the way, should be this certificate from IHS. So I'll enter this command and extract the serial for it, and take a look at this. We have exactly the same serial, just like we expected. So in other words, we just saw this. Now what we want to see is this here. So to do that, we need to look at cell root here. Okay, here's my command to look at that. We'll extract out cell root, and we get this serial here. So which of all of these key.p12 files contains that particular certificate, that serial number? And just to be clear here, this is the core server, and this is the analytics server that you're seeing in our Linux screen here, meaning this core machine here and this analytics machine here. So now what I'm going to do is run a find command that will look for every single key.p12, run a key tool verbose listing on it to get all the details for each of the contents of those, and then save all of the contents to a /test file. Okay, and then we will open that up. And when I go to the top, you'll see the key tool command that we actually issued, and then the contents. So the question here is, we're looking for cell root. Do we have a cell root with that serial number? So I'll do a search for 8E3D0. And yes, we do. We see it right here. In fact, if we scroll up here, we can see which command it was that we ran that found it. So in this case, we found it on this node. And in fact, if I were to copy this and paste it into WAS, so we'll do a find and then paste, and then sure enough, here it is. So if you're wondering, well, wasn't that the default key store here? We can copy this and go look. Okay, so I'll search for that down here, clean up this /, make sure to escape this one, and then sure enough, there's that entry, but it doesn't match the serial number here. So if I keep scrolling down, because there's more than one key in this key store, then eventually I will get to the correct serial number, and sure enough, they match. Which means that we found that entry right there. Now, if you don't do this, if you don't have one of these certificates in the key store that it needs, if, for example, it's not in the plugin key store, then you are going to get error messages, and generally they'll come from GSKit. So, and they should be pretty obvious, things that say this certificate was a bad certificate or it just wasn't there. You also have to make sure in the newer versions of WAS 8.5.5.7 and higher that the criticality setting is set to true for the certificate revocation list because of a change in the underlying GSKit code. So if your certificates say something about criticality equals false, then you're going to have another GSKit error message, probably one that refers to the certificate being invalid. Also, notice that if we look at the root CA cert and we get its serial number, it will also match a listing inside one of the key stores. In this case, we're looking at let's go here, up one more, and we'll see it's in this ICFM node. But hopefully you'll notice a mistake there. If you have root CA certificates or intermediate ones, they should not be going in the key database. That's not what they're for. They should be going in the trust database or the trust store. So here, for example, should be in the trust, not the key. These are for leaves, and these are for intermediate and roots. But in plugin key, we don't have this distinction, so you have to put them in here. And you can confirm that because if you open up the plugin CFG, which is the configuration for the plugin, and you do a search for trust, there is no such thing. And if you list out all the contents of the folder that contains our database of keys, so the plugin key here, you will see that there is no reference to any intermediate or trust database. In other words, we're saying that both the trust certificates and the key certificate, both or all of those, need to go into the one key store in the plugin.